Welcome to Developers Meeting on Sunday, the 16th of July 2023. Very hot here, so I hope you guys feel better. And Ido, please kick us.
Yeah, so unfortunately we didn't get much progress on Aloha this week. Both I was traveling, Fabio got sick, and we didn't get a chance to meet. So hopefully we'll meet this coming week. The plan right now, because we have a lot of developers that are coming and want to help, is actually continue the restructure of GitHub, moving to a single repository and create all the GitHub issues that we need in order to complete the Aloha version, both from software and hardware and readme, guidelines, whatever. So once we complete that, it will be much easier for new developers to look at the issues, see like a first good issue that they can pick up, start having discussions around this issue on GitHub, so we can all kind of reply and not wait for this meeting or offline to kind of discuss it. So it will be a bit more productive. But again, unfortunately, that didn't happen. We just life happens, and both Fabio and I has babies, so it's quite challenging these days. That's pretty much from my side on Aloha. Another good sign, I got the Orange Pi 5 Plus. So it has 2.5 gigabit dual Ethernet ports. Better, I think, more PCI lanes for the PCI Express, so we can get better throughput. Same 5 volts, same size, so it's not much difference. Price is pretty good, around 150. Cool. With 16 gigabytes of RAM. Yeah, it's pretty good board.
Okay.
Yeah, the boards are definitely getting there where we need them to be. It's good. So let's continue with Yannick. Yannick, you did some work.
Yes, I did a little bit of work the last days. In the idea channel, we started talking about if it is possible to estimate the distance with the fisheye and the PTF to objects.
Yes.
And I asked myself then if we can characterize basically the uncertainty of the distance estimation with the two cameras, and how that uncertainty might change with, for example, the distance that we have between both cameras and so on. And so I started doing a little bit of work concerning that. And maybe I can start sharing my screen, and maybe I show you the whole screen, if that is possible. Okay, I think that's it. Do you see my screen now?
Yes.
Okay, so maybe I start with this slide. So I never worked on that problem before, so I just started to work myself into the basic trigonometry stuff, and this is just a sketch of that, and we can see the fisheye here and the PTF and our object and how these relate to each other in space, basically. And I started coding that here, and I did that yesterday and today. And the first step that I did was I calculate the distance to the object with a given azimuth and elevation angles from both the fisheye and the PTF. And by the way, should I increase the size here, the font size?
Oh, that would help.
That would be great.
Yeah.
Okay.
Quick question: what was PTF? What does that mean?
Paint tildes
Pan-tilt
focus.
focus.
Right.
It is basically a telescope that can be tilted up and down, panned right and left, and has a focus control so you can get an object sharp.
Okay, cool, thanks.
Right. So is this fine now? The font size, I mean?
Yeah.
A little
Okay.
bigger for me.
A little more.
A little bit more.
Please. Out.
Okay. Okay,
Yeah.
better?
That's nice.
Okay. So I started by calculating the distance to the object from the azimuth and elevation angles, and it's not much math. It's actually quite simple, I think. And I hope it's correct now. I think it is. So I did that. Then we get the object coordinates here, given the azimuth and elevation angles. And then I did the back calculation just to make sure that I get the same angles back, just as a small sanity check, so to speak. And then what I did next is that I want to calculate the distance to the object with the object coordinates given by myself or another user, basically. And then what I wanted to do is, for example, change or iterate with the azimuth and elevation angle from minus, for example, minus 0.1 to 0.1 degrees. So basically including an uncertainty in the azimuth and elevation angles of 0.1 degrees plus minus. And looking then, I mean, I'm new to this, so I don't know if an uncertainty of these angles of 0.1 degree is realistic or not at all. I have no idea. It's just a wild guess that I made that this could be realistic. And then checking how this relates or affects the distance calculation to the object. And after that, after I do the iteration, I just make a histogram of that. And I've already put this onto slides. So I just basically coded that. So I hope it's correct, because when we have a distance between the fisheye and the PTF of 0.4 meters, I think that's the current plan.
Yeah.
Then the histogram looks like that currently. So it was a little bit surprising to me, because I thought the distribution would look a little bit different, but that's what I got out right now. So everyone is invited to check my code, of course, on that. And the uncertainty would be around 50 meters based on azimuth and elevation angles of plus minus 0.1 degrees. Now, when I end object coordinates of 1 meter on the X domain, 50 meter in the Y domain, and 100 meter on the Z axis, when I change that now the distance between the two cameras to 1 meter, we see that actually the uncertainty gets smaller. So we get, and that's what we expect. Yeah, if we increase the distance between the two cameras, the uncertainty should go down, basically. And so it decreases to 20 meters. And then when we change the distance to 10 meters between the cameras, the uncertainty changes again. And what you also see is, what was kind of surprising to me, is that the distribution function also changes with that. And the uncertainty decreases to 2 to 3 meters. And I also tried a distance of 100 meter between the cameras, and then the uncertainty is around 1 meter. So this is what I did, and I invite
So-
everyone to
Hey,
check
Yannick,
my code because it's very fresh.
Hey, Yannick, I have a question. Are you using
Yes.
the focus in your calculation?
No,
Focus.
it's just taking the azimuth and elevation angle from that we would get from the simple tracker on the fisheye. And that would relate to a calculation that we make, basically an azimuth and elevation angle that we need for the PTF to focus on the object. So we have two sets of azimuth and elevation angle. And this is this here. So I calculate, we have from the fisheye, we have the azimuth angle, so the horizontal angle, which I call here alpha 1 in this case. And then we have the elevation angle, which I call beta 1. And we also have, for the PTF, we have the same set of angles, basically. And that's what I use.
So quick question. In real life, we don't know the coordinate of the object, correct?
Yeah.
So
Yeah,
we actually
that's true.
No,
Yeah.
Why not? Why not?
Well, we can calculate it if we have these angles.
We have everything we need. We have rotary encoders. We calibrate them. We have our north or especially south adjustment. We have everything that we need. So why don't we have any coordinates of the object?
No. My confusion is that because in the real life we infer the coordinate of the object.
Yeah,
from the
that's
angles,
totally
right.
that's totally true. But
Yeah,
for the
so-
uncertainty estimation, I went the other way around, basically. But only for the uncertainty estimation.
Yeah. So that's why I'm a little confused, because the figure shows that we know what the coordinate of the object is. I think what's more interesting would be like, given the coordinate, given the measured coordinate, what would be the range of distance that we could observe? Like, imagine we see angle.
How we start out here in the beginning, how we start out here in the code. I mean, I definitely invite you to check it. I mean, you are a physicist, right? I'm only a climatologist, so you should definitely check my code. But
sorry there, Ralph.
Well, I mean, it's only basic geometry, but who knows? We all produce bugs, I guess, here and there. So
may I say something?
I start out. So just let me say.
Okay, go ahead.
I start out with the fisheye azimuth and elevation, and also PTF azimuth and elevation, and from that I calculate here the object coordinates. I mean, I went through it now very fast because I just want to give a summary of what I did.
Oh, I see.
I think we can later on we can go more in depth. But yeah.
Oh, I see. Thanks for the clarification. I thought you assumed there was some known object coordinate. I was just confused by the label.
That was my first step. Go from the angles to the coordinates, and then my second step was going back to the angles again, just to check my calculation, and then
introducing an uncertainty.
Step 3 was the checking the uncertainty, and then because it's easier, just going from the coordinates of the object back to the making the distance estimation based on the object coordinates. Yeah.
Is there any way we could get more accurate uncertainty estimations based on the actual hardware?
I'm pretty sure about that, because this 0.1 degree uncertainty that I plugged in here, I mean that's just a wild guess.
Okay.
So definitely
we can get down to 1 arc minute.
Okay.
From the fisheye, and if we are lucky and build it right, we can go down to 0.5 arc seconds for the PTF, because we are seeing limited.
Okay, so we have two uncertainties, one for the fisheye, one for the
Yes.
PTF.
Yeah, so just another random thought. I don't know how realistic some of these parameters might be, and I don't mean the uncertainty, because if you look at, for example, airplanes, their altitude usually is quite high. So it's on the order of, I don't know, thousands of meters. I wonder if the conclusion would change drastically.
Yeah, that might be the case. So I just made a start, and I'm not finished. But that was also the idea. So we can change basically here the coordinates and do the analysis. And what I also started doing is I wanted to have a little mini app, let's say, where we can do that basically, or a user can do that dynamically. So I just started that. It's not finished at all. And yeah, you are supposed to have sliders here where you can change the object height and so on. But it's I made a start on that.
And the outcome, what shall be read from these graphs?
From this one here?
Yeah.
This should just be visualizing the triangle in 3D space. And I want to have a uncertainty estimation here as a histogram. So a user is able to change these parameters here. And maybe also I should plug in here the uncertainty of the angles as another slider. And then see how the uncertainty changes with that when I make a change here. And I think that would be very interesting just to get an intuition how this all works. And I think it would be helpful. For me, it definitely was helpful because I had no idea what the uncertainties could be.
Yannick, wouldn't at the end the result be a graph that shows uncertainty depending on distance? Distance to the object.
Yeah, the distance between the cameras.
No. Let's take that as a given for now. I mean, of course, if you make the distance 2 meters, then it's better than a half meter. Of course, we know that. But if you just fix the 0.4 and move the target object farther away, like Tim said, let's put it 10 kilometers away, how would that inflict the uncertainty? Would it be linear, or is there?
I have no idea because I haven't looked at it yet, but we can definitely.
Okay.
So I wanted to do that.
Yeah, I imagine.
But I have to. That's something for next weekend.
Perfect. Cool.
Yeah, I imagine there's some upper bound. Like once the thing is too high, the angular difference will be exactly the same for two cameras, and then there's no resolution power anymore.
Yes. The resolution is defined by Rayleigh criteria. That's what I'm telling you for the last 2 years since we started it. And this is what comes here into point, because the method Yannick is presenting here, it's already used in calculating the distances to meteors, asteroids, and something like that. And it is sound. So yes, I can approve that. But Tim, you're right. There is a problem with the distance to the observer, because if it is too low, then these calculations will fail. And if it's too far away, let's say more than 3.5 astronomical units, then these calculations go berserk too. So there is a range where you can use this method. And the more something is in our atmosphere, the seeing distracts it, and these calculations are very, very rough. So I would say from my experience, the calculated uncertainty is more about 100 meters or more. But for getting to know the stuff, how these things work, how the geometry is it, how the topology is it. I think this is a good work Yannick did here, because it gives people quite a view how things work. And so it's sound.
Yeah, and you can also, of course, apply that same method to the scenario where you check how far apart do you want to have two different Sky 360 stations.
Yeah.
Yeah. So, yeah, I'm going to continue working on that next weekend, and maybe then I have a little app where eventually I think that's a good idea, that we basically integrate the uncertainty over a range of heights, right?
Distances. Yeah.
Yeah.
And this is the one station interior setup. But you were also mentioning, let's say, one station is 20 or 30 kilometers away, and each station is surrounded by 5-6 others. How would then the uncertainty decrease?
Yeah, then the calculation changes. I found one or two papers that I can look into for that. Because then it's an over-determined system, and according to my understanding. But,
yeah, you can probably just... Sorry.
Yeah.
So question, why don't we use, lat-long coordinates?
That's the result.
Yeah, and the other thing that I wanted to say is this calculation. Yeah, this calculation now is very simple. It's not. It's just triangular. So when the distances are like on a meter scale, it's no problem. But when we go to the kilometer scale, at some point we would need to change the calculation, because it's just as I show here. It's so the C line here is really it's not curved, so it's at some point we would need to change to the spheroid system, but for small distances this is fine.
Well, wait a second. If we talk about only the one station, we can assume that the 40 centimeters do not are not inflicted by the curvature of the Earth.
No. I mean, when we look at two different stations that are, when you talk about 10 kilometer, 20 kilometer, then it is gets important at some point.
Yeah, I mean, you can probably just do some sensor fusion. Like each sensor has some 1 sigma band of location, and multiple ones you can just add them up statistically. So the region of how far it is will shrink. It will shrink like square root of n, so it wouldn't be that great. But
using a Kalman filter would do that very good.
Yeah, so this is just intended to have a small tool to build intuition how the uncertainty might change with these parameters. So that's how I intended that. Actually, also for myself to just get a feeling, a feeling for that.
The good thing is that this is a data point itself, because when there is an object that is detected by both sensors and we estimate a distance, then we also already have the probability of that distance, or the accuracy of that distance, not probability.
Yeah. So I'm going to upload that to GitHub, to my GitHub, and I'm gonna share the link. And then anyone who is interested is very, very much invited to double check it.
Cool. By the way, you're playing on your GitHub. Shouldn't we bring your stuff onto our GitHub?
Yeah. We can definitely do that.
I mean, you have already did some modules, so Ido, wouldn't it make sense to bring his stuff over to our GitHub?
Yes, but he can keep it for now in his, and then we will have space on the new repo for that.
Okay, so when you're done with the restructuring, then we put Yannick's source into. Okay, and the same is true for David, as far as I know. He has an own GitHub as well.
Okay, so I think that was all from my side. So I'm going to share. Stop sharing.
Yeah. Thank you, Yannick.
Welcome.
Thank you very much.
Yeah, so I think it's an important data point to estimate. Yeah, we already knew in advance that a 40 centimeter is not big, but the option is to put several cameras on several distances, and not everyone on this planet has the means to do so. So if there are people who can have who have big yards and put cameras on 100-meter distance, they will certainly have better results. But let's say the one who has just a balcony, for example, has a reduced space, so we have to live with a 0.4 meter distance between these two sensors. But that's it. I mean, every measurement has its specific accuracy then. But so it is.
Perfect to create more debate, right?
Pardon me?
Perfect to create more debate in a way, because if we get ambiguous evidence, it's interesting, we'll get some attention at least.
Yeah. One thing is that what we already tried to implement, or let's say that the philosophy to is that not only one set of hardware can be used, but there will be better hardware in the future that we also support with, and they have different accuracies. So that's something we always have to implement along the line.
Well, that shouldn't impact how we triangulate. So
only the accuracy, not the how-to. No.
Yeah. Once we get to that point to implement it in software, there will be like a specific subsystem that is designed to, take all the coordinates from all of the sensors and create one with a proper confidence. So that's why I was speaking like on the side with Christian. I'm thinking maybe that subsystem should be based on geo-coordinates and a spherical kind of math. That's what I'm used to, honestly, from working on that stuff before. But I don't know from the science side, because the more raw data is like the XY coordinates from the sensor, but maybe I'm thinking maybe each sensor can report again geo coordinates, so we'll have a library that allows to transfer from XY coordinates to geo coordinates.
No, there is none.
And
sorry to say, from a single sensor you cannot derive 3D coordinates.
Well, you derive, and you derive it with certain confidence. Okay, so what you create like an hypothesis for the fusion subsystem to actually take it and make it better, right? And you create like what is called a starting point distance that usually you can put it in the median, right? So it's between the middle between let's say 40 meters or whatever and ISS, right? Of course, with one sensor, you just have the distances in the middle with very low confidence in it, which means the vector of the possibilities of where the position is somewhere on that vector. And then if you add the PTF to it, then there is that vector, and you see where the two can match, right? In that confidence, and that reduces that increases the confidence, reduces the possibilities where the object is, and then you have a passive radar, and the passive radar comes with his confidence, with his possibilities, and you merge those as well, right? And you increase the confidence by that as well, and what's important here is to understand the confidence levels that you can have in each one of the sensors, right? Because fisheye confidence will be very, very low. The PTF will be probably better, but both of them will have zero confidence on the position, right? But still something, because you want to have some kind of accuracy in the system, right? Now, I think that will be like a more reasonable thing, to do it. It's definitely more challenging because of the spherical side of things. Another way to do it is kind of UTM, and then that keeps you on the Cartesian coordinates, but that's a mess. You're losing a lot like that.
So just a thought, 100% agree. I think this is very Bayesian approach, and I think usually in physics you just simulate it, just some bootstrapping, and you can say, hey, 95% confidence interval. Choose your confidence, and then you can draw a circle in the sky, be like, hey, that's
Yeah, exactly. Like what I did back then is actually I tried to use like the GPU and circle the circles and see where the color change to improve the parallelism of this fusion. Right, but back then no one used it for GPU, so and that never saw the day of production really. Like we still use CPU for this fusion back then. But today you can do so much more with it, I think. Now that we have CUDA and all of that, that can be a very straightforward kind of pipeline.
A quick question in regards to the triangulation. Do you need to make assumptions about the size of the object when you do that?
No, it's the other way around. The distance calculations are used to determine the size of an object.
Yeah.
If you know the size of an object, then you can determine its distance. But since the distance can be estimated much more easier than the size of an object, we will use it the other way around. Because for determining the distance, we not only have the optical sensors, we have ADS-B, we can use DVB-T, or satellite information, and we have other audio. We can use we can put stations together to get a better estimation. But
Roger that.
From just looking at an object, you can't determine its size or its distance. You can determine the angular size matched to the amount of pixels, but from that you can't determine anything about distance and its size itself. So,
right.
But using the one for the other is a good way to start.
Yeah.
Okay.
And also, Yannick, I think that will be good, something to kind of build on the simulation. So you can try reach out to Massman because he might be able to guide how to do that. Because most of it, like you can create in what it is. I forgot that game engine that uses. Unity, Unity. So he did something in Unity, and you can create also the entire fisheye lens in it. Yeah, so that will be cool to actually visualize. Like under.
Yeah, definitely. If he has time to do it, I have no. I mean, I don't know how to use Unity or work with it.
Yeah.
But
so
if he is interested, of course, that would be great.
Okay.
Yeah.
And also some random things to point out. This is good work initially. I don't know if people have mentioned about atmospheric effects. There could be refraction. The light could get bent slightly. In the future, that could be something to look into.
Yeah.
Especially, yes, we're talking about it. I'm talking about it with Richard for, let's say, how long do we know each other? we did it right from the start. Yes, we're aware of all those things that come with the atmosphere, and we're working in the background because I do it for my astronomy stuff all the way long. We have models for that, but you mentioned a very important aspect about it, and you all did. Maybe it's good that we buy another Mikey Optics, take it apart, and do measurements about all the lenses inside to get a proper model of the projection. If we can, if we know how this works, we can let that be put into the simulations for that, and can calculate very proper images of what to expect.
And I was also reading the Galileo project paper that was published, and they also talk about synchronization between the different components as being a source of inaccuracy as well.
Yes.
With the clocks. I mean, I'm not familiar with we're using ROS to communicate between the different components, correct?
Yes. So I'll speak more to that. I actually spoke with Galileo. I was supposed to help them also last year. Everything hit south for me. Anyway, because timing is crucial to do any sort of kind of tracking in fusion, we are going with ROS2, robotic operating system, that has the DDS protocol, which is a real-time protocol exactly for such purposes. Obviously, the different computes will have to be time synchronized, and that's what we do with normal NTP to start. And we can get very advanced here, with Boyan's help on doing even a hardware level solution to optimize the synchronization, right? And also, on the timing itself, we're getting the time from a GPS dongle, so that will help as well. Okay.
Okay. So now, we're going to have a GPS dongle on the.
Yeah, but I want to emphasize here another thing. Okay. When you speak about real-time system, it's not about that it took like sub-milliseconds or whatever. It's about guarantees of time windows, okay, and deadlines, okay. So think about it that when we receive a new frame from the camera, because we know when the last frame was received, now we have a window of possibilities, and that's what needs to be taken into consideration by the next component that looks at that. Okay, so it's not like a fixed time. It's possibilities of times. Okay.
Makes sense.
Yeah, and again, that results into a confidence, and based on that, you can get the proper velocity and everything else.
Anything else on this side, on the Aloha? I want to emphasize that we have a new channel on Discord for the Aloha version. It's called the Alpha Aloha, and it's only writable, accessible for developers. Okay, everyone noticed? Please say yes.
Yep.
Okay. Okay. Yes. Great. Cool. So, okay, the channel's purpose is for exchanging for the alpha only.
Yeah, and we will kick it once me and Fabio do our work together. Hey, Fabio, how are you feeling? Just so you joined.
Yeah, I'm better today. Thank you.
Good.
Cool. Good.
Yeah. You have anything to say, Fabio, or not really?
No, not really. I'm still investigating the ROS2 stuff with the big messages because that's what's bothering me the most right now. So
okay. So just to clarify, we are facing now. We see signs of a slowdown on a large blob filer that DDS is transferring, ROS2 is transferring, and we suspect there is a misconfiguration in the DDS in ROS2 around, again, large objects. So it could be that there is too much memory copy, or we are not declaring it properly for a large blob. So that's something we will fix. That ROS should be able to handle that easily, because we are using the same compute, so that shouldn't create any hassle. So
yeah, so right now, if the image is like over 5 megabytes, then it drags the whole system down. The transfer between the nodes. And that's the whole reason. If it's lower than that, it's just instant. But that's the problem.
Yeah.
Okay. Yep. You guys gonna fix it?
Yep.
Okay. If there is not,
if you wanna see, I can just show I can just show a demo. It's running, on a lower resolution than in the highest resolution. I can just showcase it. I have it running here, so.
Go ahead.
Yeah, sure.
Yes, okay. Second. I have to set the screen, the whole screen. Okay. Can you guys see my screen?
Coming. Yep.
Second. Yes. So it's running with I just resized the image from the video, okay? Mm-hmm. So you can see that it gets as fast as we can, getting the image from the video and just putting the bounding boxes and doing background detector, and show the background detector here. So it's just blazing fast. But let me just stop it here. And if I turn the resolution to the full resolution, just build it. And if I launch the video, then, and that's from the video, that's a 6 megapixel image. So you'll see that's,
wow.
It's not handling it okay. So I have to figure out why. I'm searching ROS2 forums and I start asking people what can we do to improve it. So that's where I am right now. Mm-hmm. So it's just and that's not even the 20 megapixel image. Mm-hmm. That's just the image from the video. That's a 6 megapixel one. So no, not 8 megapixel, but.
Mm-hmm. Is that on an Orange Pi?
No, that's on my PC here, so it's not on the Orange Pi. But it's the same. It's for this specifically video here. That's the same. So
what is the CPU consumption?
You on this, or that's running right now?
Yeah, on your computer, like when you run.
i9 with like 24 threads, and that's the one. The previous version. It's let me just check it here. It's the 20. That's the second.
No. What's the CPU consumption? Not which CPU you have.
Okay, I can check it, but since it's running on WSL, it will not be great. Let me just check it.
No, I want to see if it's like.
Let me put it here, so it will be easier to see.
Okay. Yeah.
Let's launch the video. Let me share again. So I have the video here running.
Yeah.
I have the CPU. So
yeah. So it looks like you have a lot of mem copy, honestly.
Yeah, on this case, but it's running on WSL with ROS2.
Yeah.
So it's not the perfect situation running directly on Linux or anything like this.
Well, WSL should not take too much.
I know, no, it's not. It's not taxing the CPU too much. It's not a CPU problem. It's more on the I/O or something or on bottleneck. So it's not a CPU problem, no.
Yeah. I think we need to define this structure differently.
Yeah, that's true.
Why is the memory consumption?
That's why.
Why is the memory consumption so high?
I can check it, but I have a lot. It's mainly the WSL, the VM running.
The virtual machine, yeah. And why is that one so big? Machine. You can't say probably because of virtual machine.
Yeah, it's running, not running directly on Linux. So
you
it's pretty good, but it runs the same on when I run on the Orange Pi. It's just easier for me to test here because it's faster for me to compile and test than the Orange Pi directly. So
okay.
Could you try running like top or HTOP in VSL? Because I'm thinking that maybe the memory that you are seeing the VM use is like the total memory usage of the VM itself, and maybe also the processes running inside it.
Yeah, I tried running directly on the Orange Pi and checking the memory there. It's using almost all of the top 12 gigs on the Orange Pi itself. But so it still has memory, but it's not a memory problem. It's something else.
Wait, are you using the GPU? Are you using the GPU? This is just for streaming, right? The GPU.
No, it's not using the GPU at all. It's not using the GPU at all.
What is consuming your GPU one?
No, it's consuming because just for the display. It's just for the
rendering.
Display, so.
Okay.
Yeah, just for the rendering. But for the core itself and everything, it's not using the GPU. 50%. Because I'm not using any CUDA or anything that might use the GPU or OpenCL.
I'll explain. There is a way in system like that, like FastDDS, there is a way how to handle messages. Okay, most likely that's what it is. I'm trying to share a screen.
I'll just share here. Just a second.
Yeah. A second, I'll show.
So it's like this. It runs very fast up to a point, and then it starts to dragging. I don't know. It's trying to stitch together it cuts the message in several pieces, and then it tries to stitch them together. It's a mess.
Yeah. So So in DDS, FastDDS, I think there is a way to design the messages to either be long, which means you're copying them, to do zero copy, so they're sharing only the pointers. And that happens in the same compute. I know, again, Eclipse has it, I know RTI has it, and FastDDS has it for sure. I'll share this with you, Fabio, but there should be a way how to properly define it in C++. I think.
It seems I'm using even shared pointers for not copying or anything like this for the translation between OpenCV and.
No, it's not between OpenCV. It's how the message is defined when you publish it.
Yeah, we can check it.
I'll share that with you. Okay. Most likely that's the issue. and there is an issue on very slow publishing of large messages. That's from a year ago.
Yeah. I saw that. I saw
Okay.
a lot of these messages. Yes, the same problem.
Yes. So again, most likely it's this how to enable a zero copy.
Okay, let's try it.
Okay.
Yeah, okay, perfect.
Yeah. Sorry.
No, that's okay.
Yeah, we didn't get a chance to speak this week. So I wanted to show that to you.
That's interesting.
Yeah.
No, that's it. Yeah.
And then the problem is that I'm just playing with everything on ROS2 and try to make something that it's easily copyable, so we can just copy the template node and create other nodes for other people to create the nodes themselves for other purpose, and that's what I'm trying to do here. So.
Nice. All right, thanks, Fabio. Anyone else? Ido?
No, just I guess to iterate into that, like in C++, to get the size of the object that you have is considered costly in performance, right? Because it's not that you know that. Like a dynamic object, right? So usually when I wrote C++, and that was a while ago, I would separate like an entire different structure to handle large blobs, okay? And most likely that's what happens also with FastDDS. They just require a different like structure or of how we defined it, so they know how to handle it differently, because they don't want to look inside the object for something. Yeah, I'm just trying to kind of imagine how FastDDS did it. But Fabio, if it's not in that article, it should be in FastDDS.
No, true.
I'm thinking out loud here, so I need to kind of recall.
No, yeah, I need to. I was checking how to configure everything, but it's not very straightforward because we have several different versions of ROS2 and with different implementations of blah blah blah, and so sometimes it's a little bit shady. I have to test some of them and then try others and.
Yeah, and it could be that there is just a different like publish method for large blobs, of to do zero or to publish it only locally.
Yeah, and right now it's publishing only locally. It's not using.
No, I know, but you can force it. You can actually have a message to ensure the message never leaves the compute. Because you can do that. You can configure a message to not leave the compute also.
Mm-hmm. Yeah, I can check that. Yeah.
Yeah. Okay. Cool. Yeah, that would be interesting.
So, if there's anything left, Ido, on the alpha discussion?
No.
All right. Then I would say we step over and go.
One last thing.
Yeah, go ahead.
Just one last question. Thank you very much. SNLCK, you mentioned that initially you mentioned about doing like GitHub issues for the rest of us to be able to contribute asynchronously. What's like what's your expected timeline, or do you need help, or can I contribute to fasten that? Because that's I'm kind of like looking for an angle to contribute to this, and it's difficult because I have to like get in touch with people, and I don't know where to really start.
Yeah, so that's exactly why me and Fabio needs to meet to create all those GitHub issues that align with Aloha. So then you can actually take a look at that. So it's like really blocked on Fabio and me.
No problem.
Yeah. So we are really looking forward like to meet this week, and Fabio, glad to see you came back. Like let me know when you're available. I'll work on your time, so I'll make myself available. Yeah.
Let's do it after the meeting now. I think I can now.
Okay. Cool. So we want to do that. The output of what we will have is a single GitHub repo with everything for Aloha in it, and again some research that we'll do. Probably will be like a research folder, and on that GitHub repository there will be issues with the proper tags on everyone, when everyone can pick up an issue and start working on it. And just like ask a question, and either Fabio or me will reply, and we can take the discussion to GitHub. Okay.
Okay, and you'll post a link to that GitHub page in which channel? Which channel?
We'll post it on either software or general, but maybe multiple. Yeah.
All right. Thanks.
Okay. Yeah.
I have just one last note. Using some a lot of the tips from Katya, from Kat, I was able to shrink down the images that we're using for Docker. So I shrink down the ROS2 node from 8 gigabytes to 3.2 gigabytes, and the image from the Sky 360 from 6 to like 1 gigabyte. So it's much lower now. It's much easier to work with. And if I can just showcase here how easy it is to start working with ROS2, can I?
Of course.
Okay, so I'll just share my screen again. So this is my Windows here. I'll just git clone the ROS2 repository. But this will change because we will be creating the new repository, but it's just for showcasing, okay? I just cloned the ROS2 repository. I did nothing else, just clone it. Then I just switch it, and then I'm just open VS Code inside it. Then he was here to open in container. So that's a dev container. So when you reopen it in container, it will download the container here. Let me just show. It will just download the container, and then, okay, that's it.
Cool.
It downloaded the container. The container is very small right now, so it's already downloaded the container. So I'm already inside a Linux workspace that I can work, and I can just build it. It will build it, and then I can just launch, for instance, the video. Okay, so let me just export the display, because my display is at 0. And that's working.
Oh.
One question I have is, how's the GUI working? How do you get it outside the Docker container? Using to do that.
Just a second. Let's just stop it here. So, okay, so this is a dev container that's only downloaded the ROS dev container that's published on Sky 360, okay? So it has everything that's needed for development, like all the dependencies in everything, and everything else is here. And since it is WSL running in Windows, and it's running in a Linux workspace here, it's just using X Windows to display the environment.
Okay.
And so, for instance, we have the visualizer nodes here, and this visualizer nodes is just using OpenCV to display it. For instance, the frame viewer It just grabs the frame and just displays it on the.
So could it be that it's the pass-through of like video display between WSA and? Oh no, you said you had it also on.
No, it's the same problem.
Yeah.
It's not. Yeah. So it's just using OpenCV and showing the image on using OpenCV exactly in the web window. That's it. Not more.
Okay, thank you.
Fabio,
so that's it.
Fabio, you need to explain. This is for your tool, development tool.
That's
it's
for
not about the
development.
user interface, the OpenMCT user interface.
No, that's just for developing ROS2 nodes. So, for instance, here I have my environment here. So I have, for instance, the camera the camera here. The camera has two nodes. One is the iSCAL publisher. That's the K2i camera. And then we have here the web camera that you can use the web camera to test it if you don't have a K2i, or you can also use a video. It's all configurable. So for instance, we have the launch here and everything is defined here. For instance, the video launch says which nodes will be running. For instance, we'll be running the web camera publisher node with a video output and the video path. That's this video here, for instance. Then we'll be running the frame provider. The frame provider just gets the image and for instance converts it to another type of image for the one that you'll be using for displaying. And then we have the background detector node here that will be doing the background detector and the blob detection. And then we have a display node here that you'll be getting the topics and then displaying the image from the topics. That's, for instance, for the video. If you're only doing a launch with the K2i, that will be a little bit different, the configuration, but it's mainly the same. So you can configure all the nodes that you want to run. You can enable some or disable, or you can create your own nodes. You can just create another node here, and for instance, for the tracking nodes here that we have we have the tracker provider here that runs the tracker nodes. So you can just create another one here and just build it and run it. It's just very easy to tap into and start developing. If you know any C++, very basic one, you'll be able to just copy one of the files, for instance here, and let the get from the visualizer, for this frame here, viewer here, just copy it and just change it for wherever you want it and just get it running. Very, very easy. And I can support it. So that's it.
Cool.
So it's for anyone that's willing to just dive into the ROS2 and start into an environment that's already set up and you don't have to do anything else. It's done. So you just have to go into there and just start coding. And any doubt, you can even code in Python there. Okay, we'll have a node. We'll have nodes in Python there. But but we're trying to avoid Python for several reasons. But we can do in Python, for instance, for proof of concept for some things, and then we can convert it to C++ later. Okay, but we can do in Python, we can do in C++. We just have to create another folder there, and set up the ROS2, and everything will be done. And I can guide anyone there, just if anyone needs help. Okay.
Yeah, we will provide README file for how to do that. So
yeah, true. I just wanna show that's very easy to right now, and the way that we are configuring, and that repository we move to the one repository that we're creating, and so but it will be the same. You just be cloning and start developing.
Yeah.
Fabio, I want to come back to the question of Aaron. Is there any node already in place that serves as a service for the OpenMCT user interface?
I don't know. I didn't play with OpenMCT. Dan was doing that, and if not, it's very easy to because I'm providing right now several topics with images, and also the blob detection output. So it's very easy to just get these topics on OpenMCT and just display it. So and if not, we can create a node that just like the old what was the name? I forgot. The one that puts everything together and publishes another image. We can also create that. If we cannot do that on the client side, for instance. So I can also export some nodes with the image and the blob detection, like we were seeing with the purple boxes around the objects, and I can export such things I can do in, like, I don't know, 15 minutes. I can export it. So.
Cool. Okay. So someone like Dan or Aaron can then easily pick it from there and create the user interface.
Yes, that will be very, very easy.
Yeah, maybe I could.
They already did it with the I forgot the name of the annotated frame provider. He was getting the output from the annotated frame provider, but it's just getting the output from the any of the other images that we have and put everything together. So it's straightforward.
Yeah, let's not discuss it now. There will be a GitHub issue for this specifically.
Okay. If you guys want, kind of non-leads to participate via the GitHub issues, that's fine with me. But yeah, I'm going to be, really diving into the code today and over the week.
Cool. Yeah. So if you think you can help with OpenMCT, that would be amazing.
Cool.
Amazing.
Yeah. With the integration from ROS, I can maybe look into that. Could be my first.
Yeah. So we have something. We already have something that takes something from ROS2 and put it in OpenMCT.
Okay.
We use the ROS bridge for that. And what we will need again is to look at the video. But I'll have a GitHub issue specifically for that, because I want to move the OpenMCT into this repository as well, and I want to make sure that it's running and operational for development. Okay. Yeah. So, Fabi and I have a lot of work to do, honestly, for that. It's not as straightforward to make it available for everyone. So.
Sweet.
Yeah. Cool. Richard, you want to continue with?
Yes. Okay. So let's continue here. Today we have a new developer / scientist with us. It's Tim Liu, and maybe Tim, you can introduce yourself again quickly so we have it on record. And then you can maybe emphasize what your goal is, what your ideas are. You certainly have thought about it.
Yeah, certainly. Thanks for the introduction quickly. So my name is Tim. I have a PhD in theoretical particle physics, and I did a postdoc in the same area for 3 years. And since then, I've left academia. I'm currently a data scientist, dealing with big data, data science and stuff like that. So the reason I got interested in this Sky 360 project was recently there was the NASA announcement on some of the UAP studies, and it turns out when I watched the announcement, the head of the research program was David Spergel, which was a professor at Princeton that I interacted with a few times. He was a very, very bright guy. So I was quite intrigued about some of the results that they presented. And I thought, it will be interesting to find more scientific information. But unfortunately, of course, the NASA announcement does not come with data release or things of that sort. And I found out, and digging in different places online, I found you guys, Sky 360. Seems like it was a citizen science project, so I thought, maybe I can come check it out and see what that's about. So I think my intention comes from a position of curiosity. And also, I think, perhaps there's certain things I can help because, throughout my PhD and my research, I mostly write papers on, I write papers on roughly two categories of things. First are things that are highly theoretical, like theoretical physics, particle physics models. But probably the majority of them are involving linking theoretical ideas to experiments. So I spend a lot of time scrutinizing data from, let's say, collider physics, interpreting their results, see if there are alternative modes of interpretation that may support or discredit certain scientific hypotheses. So I thought this level of expertise, and I wouldn't say I have particular expertise, maybe other than like very specific particle physics topic, but just this general, I guess, appreciation of examining experimental data, examining different hypotheses, and writing published papers about it could be of use to some of you guys. So anyway, I don't know if you guys have questions, thoughts, concerns, let me know.
Yeah, I start off with the questions. Christian, do you have any questions? So otherwise I start off.
From the scientific point of view, what's it that you like best about Sky 360 that you learned so far? I'm asking that if you have an idea if you want to take part as a developer, in which direction your efforts would go.
Yeah, I think it's hard for me to say what I like best or not like best. I think I try to keep as neutral of a perspective as possible. Like, obviously, if you guys have data and I can get my hands on some of that, I'll be quite pleased, probably. So I'm sorry that can't really answer much of that question. In terms of contribution, I think as a developer, my coding skill is all right. Like I know C++, Python, maybe a bit of Java, and recently Scala. But probably I'm not the best developer. like my code, I probably don't write enough comments, don't write enough unit tests, don't think about integration as much. So I think the help that I can give is probably maybe along the scientific fronts, like and data analytics. Like for example, some of the results that Yannick was presenting earlier, like that stuff I can probably help out. Maybe we find a little bit, put some more rigor in it, stuff like that. Or maybe the data science aspect, like how do we make an informed decision based on data? How do we incorporate different uncertainties and make kind of like a scientific measurement as opposed to just having data? So I think those are slightly two different things, but so does that help answer some of the question?
Mm-hmm. Yes, because I was thinking if you like contributing on the dev side, because we do not have anyone that goes very deep into the atmospheric disturbances, might that be some kind of topic that is suitable for you?
Yeah, certainly I can dig around, probably doing some investigative work into the literature and see if it actually is a factor. I think that's probably the first question one needs to answer. Yeah, certainly some preliminary thoughts I can write down and help some of the discussions.
Yeah, I think this would be a good start. What do the other think about that?
Basically, people are best when they work with something they're very interested in. So I wanted to find out from Tim where his emphasis are, what is his, what drags him most. It's not that we have to fill up a let's say a task and find someone who is stupid enough to do it. Sorry to say, this was a joke. Hard to formulate that. So Tim, well, maybe Christian. Okay, sorry. Maybe Christian, you can lay out a little bit more in depth what you were actually asking, because I'm not sure whether you made clear what it is about.
The topic of atmospheric disturbances is a special one in astronomy, in using optics and things like that. And there is still no good model out there that can be used to reduce optical data. And if we can find a solution to that, here with Sky 360, that would help other scientific projects as well. But getting to know how we can deal with those disturbances, how we can maybe pre-calculate in the area we are in. We do not have very large sizes of diameters here, but if we can find a solution for a model that maybe concerns particle physics, this could help us by dealing with the problem of correct positions, because you know already that below 30 degrees above the horizon, the air mass is so high that we can't determine any positions anymore, and we can't calculate or estimate the brightness of an object because of the refractions of the atmosphere. And these are things that have to be dealt with. Otherwise, we have to skip all this area, because we can't do anything with the information we gather there. And if we would have a very nice and correct model, we could make use of this part of the horizon, of course. And that's why I'm asking, because it's a very important issue that we didn't deal with yet, because we don't do any analysis at the moment.
Have you guys tried to quantify some of the effects? Because I imagine the first step would just be to be understanding. And to be fair, I have not interacted much with astronomy data, even though I have an interest in astrophysics, but it's mostly much more abstract, I would say, like things like dark matter, cosmology. But certainly I would be able to help digging into some of that literature, just reading physics papers and help start with some discussion. But I wonder if you guys already have some preliminary understanding, some thoughts on the subject, my contribution might be limited. That's all. So
yeah, I'll be happy. We're in astronomy. We're dealing with the effect of seeing of the air disturbances for quite a long time. Since digital cameras are out there, we're dealing with it, because in the age where film material was used, the particles were, let's say, they were not that fast to encounter the seeing, and you were working with very, very stiff and still images. They didn't move, so you were not aware that we are seeing the atmospheric effects were not there. But with digital cameras and let's say 20 to 25 images per second, you have a time resolution for the seeing, and the images are disturbed much more. And because of the sensitivity of a pixel with a CMOS sensor, it's becoming more and more a problem, because seeing is limiting what you can resolute, what you can resolve, blurriness, things like that. And in astronomy, Yeah, for long-time exposure, you can use a laser looking into the atmosphere and recording that and vibrating mirrors to solve the problem. But with that little equipment that we are using, there is no there isn't any solution yet, because how this problem impacts us is not even determined.
So
it's not done easily.
So has the Galileo project published anything on the topic?
I'm not aware that there are any publications about that. There are several papers about atmospheric disturbances, but they don't provide any solutions, and their understanding of the atmosphere is very low, because it's normally nothing where you put money in so you get any results.
So basically your idea is to create a kind of stabilizer function to stabilize the area below the 130 degrees, or beyond the 130 degrees. Yeah.
And work on the model that about the atmospheric disturbances that we can expect. Because there isn't any model.
But how did you astronomers work up to now? You stack them, and by stacking you remove
we
the
don't
seeing.
No, we don't do any observations below 30 degrees above the horizon. And for the other parts, we monitor where we are in the sky. We have we can't do anything against the seeing, but we can monitor it. We can write down how much air mass we are facing at the moment, and this helps by some quality calculations. We say, okay, if we are very below, let's say about 40 degrees above the horizon, we say, okay, yes, the image is not that clear because of the height, but we can't do anything with those informations.
So I can imagine two perspectives going to this. So it depends on the goal of the observation, right? Are we, like in astronomy, we want very detailed measurement of stars and the spectrum and whatnot. But here, that's not necessarily the goal. Maybe something like an existence of something is enough, and maybe the statistical significance is lower. But if, let's say, instead of seeing, I don't know, 30 anomalies, we're seeing 60 anomalies, and maybe statistically we can say, well, 30 of them can be explained, but still 30 are left over. Maybe the bar will be enough. Like, we don't necessarily, like, how important is it that we need measurements that are as detailed? Because that's the question. And if we do indeed need detailed measurement, like the best we can do probably is to quantify the noise, how much degrades, how you know, maybe relax the limits on how usable those data is. But on the other hand, if we don't care to really measure them in such great detail, we can ask, is it enough to statistically, maybe they're noisy, but statistically utilize those data as opposed to just one event at a time. So I don't know, does that make sense?
Yes, and having a model about that we can determine if the informations we get are usable, or does it matter if we are concerned about that. This is what we are lacking at the moment.
Do we have data already available? Because I imagine it's a little hard to just speak in hypotheticals. Like, oh, maybe this will happen. But if we have, like, let's say, airplane data, like, hey, look, there's some airplanes below this horizon.
We have already recorded data. I do not know where the hard drive at the moment is, but we have already data.
Yeah, I imagine the proof of concept would be utilizing airplane data, find some ways to categorize, I don't know, how often airplanes appear, is that expected? I don't know, some statistical value. Does that conform? I don't know. You can measure the distance for these airplanes or something like that.
We went into the direction of classifying things, of separating birds from planes and things like that. And we do have some algorithms in place that maybe Yannick can say something about it. Yannick, are you there?
Yes. Yeah. I was working with my app, my triangulation app.
You worked with
I work with the kinematics approach. So this is a time series classification model. So it analyzes the coordinates of the boxes that our simple tracker gives back. So we, I don't know how familiar you are, Tim, with the whole development that we have made over the past months, but we have a tool that's called Simple Tracker, and that's for basically just detecting objects and tracking them in the image, in the video. And my code takes the coordinates of the boxes and calculates the vectors, distance vectors, and directional changes of these boxes, and classifies based on that. These two variables classifies if the object might be a plane or a bird or a cloud. And it also gives back a probability estimate. And currently, the data that we have is currently, I mean, we just getting started, so to speak. I have about 130 tracks. It's not much, but 130 tracks hand labeled what the objects are in these tracks, and I use that for training. And so I'm looking forward to increase the database for that, of course. But it was for this kinematics approach, it wasn't easy to get many tracks that are long enough to actually make the estimation based on the kinematics. And so that's what I'm looking forward to increase the database. That's the kinematics approach. And the other approach that we have is more like a machine learning inference model that Nicola is developing. And so this is more, Nicola could say a lot more than me about that. But it's a classic TensorFlow machine learning model that looks at the shape of the objects inside the boxes of Simple Tracker and decides based on that what object it might be. So is it a bird or a plane or whatever? And also gives back a probability for that. And the next step that we had in mind was connecting the probabilities of each model, so the kinematic model and the other machine learning model, and have an overall probability estimate of what the object probably is. And then we have to decide on what kind of threshold we want to have on the probability that it is a bird or a plane or whatever. And when we are below the threshold, we would say, okay, it seems to be, according to our models, it seems to be unknown. And in that case, we would slew our PTF to this target and start the recording and say, this seems to be interesting enough that a human should take a look at that. And yeah, so these are our two sort of also data science approaches to recognize or identify what kind of objects we are dealing with. So if you're interested in contributing in this direction, so you're of course welcome to approach either Nicola or me. So I'm sure our models are not perfect and there's a lot to improve. So
yeah.
So that's a different thing now. What Yannick was talking about. What Christian was talking about was some. No worries. What Christian was talking about was a problem that hasn't been solved yet. So that anything below a certain degree is so much atmosphere that we can say with a normal probability that all the measurements that for the kinematics go into play are correct or are 100% with high probability. So the probability decreases, and that's why all the model decrease then.
Yeah, so the closer we get to the horizon, the more the atmospheric mass increases, right? And then the index of refraction plays a larger and larger role.
Yeah.
And that can play a role. I'm sorry, I was coding while you were talking. So
but doesn't matter. But what I want to point out now is the atmospheric part is, of course, a nice problem to deal with. But Tim, if you are more interested in doing classificational stuff, then that's fine with me, because I think it could be much nearer to what you did in the past. And maybe it's much more interesting for you than doing that. The other thing is, for the atmospheric problems, we do not have any solution yet. And I think we will carry that around with us, let's say, for the next 5 to 10 years. Because, we're dealing with optics here. So it doesn't matter. It doesn't matter if we find a solution to that. We know how to deal it within astronomy, and we are applying the same here. But if your interests lie much more in the classification part or finding out features, that could be a good start there too.
Yeah, I guess the thought is the answer is I don't know, like because I don't have a lot of info to work with here. But at the same time, it seems like, even though this seems like two problems, but they aren't really totally different. Obviously, when you trigger the telescope or whatever you call it, the PTF, you want measurement, and the measurement could also inform to you whether this object truly is anomalous or not. So the two kind of goes hand in hand, I suppose. Sorry, but I guess my answer is I don't know. I'm not sure what capacity I can be helpful in.
So basically, Tim, it's not an issue to have an answer today. I mean, if you are still interested and join us on the meetings and join us on Discord in discussions, everything you contribute by discussion is of high value. Okay, so it's not that we have to find something for you today. Okay.
Sure.
Okay, so take it. We all have to take it easy. When we all have families and jobs and work and issues, and
Christian.
So if someone hits you, just tell us and say, okay, I want to take some time to get myself involved in that. That's fine.
Sure.
I was just thinking into the blue. Maybe there is some interest of you in that field or in another.
Yeah. So I mean, Christian, if you have Christian, right? Because your username. I don't know everybody yet, but if you have some literature or some classic textbook about astronomy that you think are helpful, I can take a look and see what I can digest.
I have got some papers about the issue because I'm looking into that issue since, I think, 2010.
Yeah, do you mind sharing that with me a bit?
Yeah.
I can take a look at these papers and gather some thoughts. So.
Yeah. There's one thing. There's a guy named Pickering. He took up the subject in 2000, and he tried to find some. Not really a solution, but he tried to quantify how one can calculate the IMAS, how it is dealing with things, and I think he's a good start because he's involved in that matter since, and his first publication was in 2000.
Can you ping me that? Because I can't just recall.
I will get you the information.
Okay, awesome.
I have to dig into my database because I buried all those papers about it for some reason, and I have to get back on that.
Yeah, just take your time whenever. Yeah, it'll just be afternoon read for me sometimes.
Yeah, I think it will next week, Monday or Tuesday.
Sure.
One other question, which is completely unrelated to the scientific portion, is: are we planning to promote ourselves at the SCU conference at all in any way?
No, we do not promote there. No, we don't.
I noticed that Ido signed up. I signed up.
Yeah, so the SCU does this every year, and we joined every year. Some of us. I was talking with Rich Hoffman, I think a half year ago, about being a partner to SCU. But at the moment in time where we are right now, we don't even have data that we can share with them. So there's no reason for any partnership at the moment. We keep it friendly. We are in the same discussion boards. We know each other very well. We even talk, let's say, every 2 weeks. We wait until they wait and we wait until we are at the point where we have real data that we can throw on SCU.
Okay, so it's not opportune moment right now to really open that channel.
No, not necessary. Okay. It's not necessary for both sides. So.
Okay, thank you. Just wondering.
There's one point, Tim. First of all, I will add you as a developer. Okay, this is just the naming form. So you get the role that you can have access to all channels on Discord, and you get access to our Drive. On Drive, you find all our sources for, let's say, hardware and software. Let's say software, not the sources, but more the concepts and papers about it. And we have a science channel where we collect all kind of papers around the UAP tracking research. So people who analyze data material and make a paper from it, or like Aaron said, from the SCU. There are some papers that are very interesting to read, and some are even with special sensors, and that would be my question to you. Christian, if you allow me to throw it in, it's there must be something that is emitting from such UAPs that can be detected with. It's a hypothesis. Okay, so what I say now is from, let's say, high particle sensors that they stack upon each other and, let's say, work like a scope that you point to some directions. Christian is a different...
Like a beam?
No, you basically take two sensors and you stack them in a certain distance. And the thing is, when you detect the same particle within the same time limit of...
You're talking about the cosmic ray detectors that we were looking 1.5 years ago. Yes.
This is still
they are stalled discussed at the moment, but yes.
Are these more or less just X-ray, gamma rays detector, or
no cosmic rays?
Like protons, electrons, or particularly
photons with that are considered to have more speed than light speed. They are high energy photons that pull through any shutter of a camera, even if they are thick metallized.
Wait, sorry, I'm confused. What exactly is it detecting? Is it just from photo multipliers?
Cosmic rays.
Photo tube?
Not only photomultipliers, but any detectors.
Like you mean any charged particle going through the detector will deposit something?
No, they are not. Photons are not charged.
Sure, like electromagnetic, right?
Yes, and in astronomy, we have a lot of photons that go through a closed shutter, which should normally not be possible. So these high energy particles are called cosmic rays because they have the same signature as the cosmic rays that are out in the Van Allen belt.
So I guess I'm a little confused because usually when we deal with detectors, either they're detecting protons, electrons, or light. Like I know that sure you can have some other particle coming in the atmosphere can shower, but ultimately the detector.
They are photons. They are photons.
Okay, so you're detecting photons. Okay.
Yeah, with the CMOS sensor, normally you're detecting photons if they are configured to detecting light, because light is made of photons.
Sure.
And there are photons that have much more energy than normal photons, because and they pass through thick mass. And these are called cosmic rays because they are accelerated so much that they can pass. And these are these incident. They if they come to a pixel, they fill it out completely. They saturate it. So
do you know the spectrum? What's the spectrum resolution? Are these X-rays, gamma rays?
They
higher,
range
UV?
from infrared to UV because other detectors we do not have. But they are available in the radio spectrum too. But there they are. The statistics are less. They are just a few over a night or a day. But in the optical spectrum, from near infrared to UV, they are quite often. And they depend, and you can detect them very easily because these are pixels that are saturated, but they are not hot or dead pixels because in the next image you take, they are in a different location on a different pixel.
I see. So what is the purpose on that? Are we trying to see if objects are emitting higher frequency radiations?
Such kind of photons. Bojan and I were working on a detector that is called Muon detector. I will give the link to the website where it is advertised, so you can see for yourself. And they consist basically of some kind of plastic material. Let's say it's about 40 by 40 millimeters in square, and they detect. They are called Muon detectors, which isn't basically the right description for what they are doing. But what they're doing is they detect cosmic rays.
I think I was confused because I think normally when I hear cosmic rays, it refers to different types of particles. It could be electrons, photons, it could be neutrons, for all I know, protons, antiprotons, it could be heavy nuclei. So I guess, because I imagine these things are probably somewhat expensive, right?
About $100 they are at the moment.
Interesting.
Yeah, and we were figuring out if this is scam or if it does really do things.
It sounds, I'm highly suspicious about $100 sensor that claims to. I'm not sure because, and also a muon detector. I mean, any detector should, if anything can interact. Yeah.
I told you that's not detecting muons.
Right,
because the muons they are in a lifetime about at best 4 seconds. It is not a muon detector. but it detects, I would say, photons with much more energy that the normal light has. But they are light photons. And they do something to the medium and this detector seems to work. We are not sure if it does, and we didn't proceed in that further, but it's a good thing that we take it up again and look into that matter.
I guess
the point is that Richard was pointing out, is there a possibility that, let's say, a cloaked craft, a cloaked vehicle, a cloaked flying saucer will emit that kind of particles, radiation, or something like that? Maybe it will emit those cosmic rays.
I think the question is a little too vague, right? Because I mean, we're not talking about specific particles. We're saying, can some unknown object emit some type of particles in such a way that the detector will respond? Right, that's the precise question, right? And it's I don't know what the detector is made of. I don't know what the background noise is. Because
at the moment you do not know that. But if we provide you the information, get you the URL of the website, then you can look into it.
Yeah, sure. I mean, I'm happy to take a look, but it seems it's almost like the chicken and the egg. It's unlikely that I think.
No, the question about the chicken and the egg is already answered, because the first chicken egg wasn't produced by a chicken, but the pre-version of it. So this is not a very good, let's say, comparison.
This is German humor, by the way. You have to accommodate.
It's solved.
You have to accommodate. Yeah, definitely. The egg comes for the chicken. Now, the question with this Muon detector is basically prove the hypothesis that it's working or not. What is it actually measuring? What is this thing actually doing? And then we still
and $100 is very suspicious.
Not necessarily. I mean,
not necessarily. Maybe. Yeah.
Could. And then we have another issue to correlate with real UAP trackings. I mean, we needed to have some real UAP tracking moments where we can say, though, this correlates with a high sigma, that it's really emitting that stuff. So yeah, it is hypothesis. Tim, UAP tracking is not something new to this planet. People already started in 1950 doing stuff and trying to invent sensors and methods to do so. And they even started with compass roses. A compass, when you put it in place, it normally stays the same. Otherwise, if you change the magnetic field around it, then the needle will move. So what they did is made two contacts, so that within a certain barrier the needle may dance, but if it jumps out, then a ring goes on. And the theory was that when a UAP arrives, that there's a change in the magnetic field. This always for me it's rubbish, because your UAP has to be very close to the sensor in order to detect it. So what does that make a sense? We try to sense. So basically, we are also inventing the stuff for UAP tracking, because you can't buy stuff from the shelf. There's no UAP tracking shop where you buy stuff. So we need to invent that material. And there's a lot of claims that sensors do this and that. And sometimes we have to test and prove whether they're suitable for us or are still rubbish. That's also something we do from time to time. Just if someone comes up with a new idea, let's prove it, whether it's working or not.
Yeah, I think the question, Tim, is if you have any suggestions of things that we might try that might detect something, right?
Yeah, I mean, one thing that was interesting was the idea of sonic boom, because if if hypothetically an object interacts electromagnetically, chances are that they must, like you can see it by light, chances are that it must be able to push charges away. And, atmosphere is made of particles with electrons. Then if it goes supersonic, it has to emit sonic boom. There just is no way. Maybe it can be minimized, can be shaped, but it seems reasonable to find some ways to detect these. And at least this is a different mode of detection. I suppose the electromagnetic, it could be pressure. But I don't know how sensitive these, speakers might be. I have no idea. It could be completely hopeless, right? There could be so much noise.
What if there is no boom because there is no friction? For example, if you reduce friction of the surface to 0, there is no boom. You don't move anything in front of you. You just slip through.
Well, I mean, you have to. Like an object is in there. It has to push the air away somehow. Like the air is not super fluid. I mean, it will feel the push. Maybe there's some engineering to. In some sense, it's a good hypothesis to think that anything that moves beyond the speed of sound should produce a sonic boom, unless proven otherwise, right? It will be extraordinary if it doesn't. Then maybe you can say that maybe it's a mirage of some kind that is not physical in that same way. But I would argue that the basic hypothesis would be that there should be a sonic boom of some kind.
Some kind of force field could make such friction unavailable.
Or if there is no sonic boom, it's something we really want to look at.
Yeah, exactly. Like I would say
the loss of physics, then it is interesting.
Yeah, I would say, given that it's unknown, personally, I would assume that the laws of physics hold first. That would be the Bayesian prior. If the laws of physics hold, as we know it, then things that move incredibly fast should produce some sonic boom, until proven otherwise. If it doesn't, sure, then there should be evidence provided for it. Then that would be great, right? So either way, I think that could be useful. Like if you track an object that is moving supersonic, but you don't record any sonic boom below some threshold, that's interesting, right? And a null result could be interesting too. So that's just some one thought.
I put the website about the Muon detector into our chat here.
How do I do this? Wait, where can I find it?
Right top corner.
Oh, okay. I did not realize that. Okay. Oh, okay. I can take a look. It's from MIT. Let's see. Interesting.
The guy's from MIT. He.
Yeah, I just need to know like what exactly is the material that's in it. What is it detecting? Oh, just a scintillator. Okay.
Yeah, the description is a little bit weird, I would say.
Yeah, I think anything electromagnetic that goes through it will produce a signal somewhat, and then maybe the response is somewhat different. Okay.
And I'm used to those cosmic rays because I have them on every image that I take in astronomy.
Yeah.
And normally, how you deal with them is they are at least 3 to 5 sigma incidents, and you can detect them, and you calculate a median value from, let's say, 15 to 30 pixels around it, and then you say, okay, at that position you want to have, let's say, this median value of it. This is called cosmic ray rejection.
Yeah.
Yes, you remove it. You replace it.
Yeah.
how could we set up a device that creates such supercharged photons, if they are these?
Sorry, what
The
do you mean?
nature of those photons, of those particles, or whatever this is, isn't known yet, because nobody pays money to look into this subject. Well,
let me just add that in ignoring UAPs, in galaxies there are lots of highly energetic particles, because galaxy has residual magnetic field. I'm sure Christian, you might know. It's effectively an accelerator. It can spin around protons, accelerate them, and as they go through the atmosphere, they can shower. They can produce secondary particles. There could be.
Take a look at M81. There is a very wide beam of particles that are coming out of the black hole, which normally would defy the laws of physics, because a black hole, nothing can emerge from there. And there is a wide beam that you can look at with, let's say, amateur telescopes. You can make it visible. And it normally, if something goes into a black hole, nothing can come out. But these are highly accelerated and high energy particles. And till now, it's not determined of what nature these are. But they do produce a reaction, so you can record it on CMOS optical sensors. And this is M81 is let's say the most known object about it. But there are others that have that beam north and south of the black hole.
Mm-hmm. Yeah, I mean the question is, there are a lot of these particles. Just you put a detector outside, you will see a lot of particles just going through. And these don't seem to have a lot of directional resolution. It's just a slab. Things go through. It can go through from all kinds of directions. And the question is, the background noise will be enormous unless there's some particular energy signature we're looking at.
I don't think that the first idea of such a detector, we were thinking of building around the PTF, having two detectors behind each other in every direction. So one is parallel to the optical axis of the telescope. The other one is perpendicular to the right, and the third one is perpendicular, facing, let's say, up. With that and using Kalman filters, we can do some differential calculations and detect if, let's say, when we move it around, then we can say, okay, is there in the line of sight to where we're pointing the telescope, is there a difference to the other directions? And these detectors, they have a metal coating above and below, so the directional, it works like a neutral filter to it. These high energy particles will pass through the metal coverage of the plastic. So normal photons, particles won't pass that. It's like a barrier in front of it.
Yeah, that's what I am not sure about. Maybe let me do more details.
Hey guys.
I mean, it certainly can't. Yeah, sure.
Yeah, sorry, I do not want to interrupt you. You can talk further on. We're still on record. I'd say we have the 2-hour limit reached. I will stop recording now. You guys, if you want, you can still discuss further on or put it in Discord. Tim, I will contact you this week for how the onboarding is, so what I need on data from your side. And yeah, with these words, I'd say thanks everyone for showing up, and we see each other again next weekend, next Sunday, and of course on Discord during the week. Have a nice one.
Folks. Before you all log off, sorry I made it here till the end, but I have a pretty hectic schedule. I had reached out about assisting you guys with some of the front end work on the console. So yeah, this is just me saying hi. I'll probably join in on the next couple ones.
Okay, great. So next Sunday, can you introduce yourself more in detail?
Of course. Yeah, of course. Of course. Pleasure to meet you guys.
Great. Good for having you. Hey, guys.